Mechanics. Mechanic can be defined as that science which describe and predict the conditions of rest and motion of a body under the action of forces. It is divided into three parts: mechanic of rigid bodies, mechanic of deformable bodies, and mechanic of fluids. As I said, mechanics is divided into three categories: rigid body mechanics, deformable body mechanics, fluid mechanics. Rigid body mechanics is divided into two categories: static, which are the summation of forces in x direction has to be equal to 0, and summation of forces in y direction has to be equal to 0, and also summation of moment has to be equal to 0. And dynamics, the summation of forces in x direction and also in y direction, and also the moment don't have to be 0 because the motion and the body is not in the rest, it's in the motion, so it doesn't have to be equal to 0. Second, deformable bodies mechanics, which are thermodynamics, solid mechanics, and mechanics of material. And the third, fluid mechanics, which are incompressible and compressible. Statics. Statics is a branch of mechanics which study the effects in distribution of forces of rigid bodies which are and remain at rest. In this area of mechanics, the body in which forces are acting is assumed to be rigid. And statics is also divided into two categories: concurrent force and non-concurrent force. Concurrent force system is also divided into two categories: finding the resultants in equilibrium. And also the non-concurrent force system is also divided into two categories: finding the resultant in the equilibrium. And the equilibrium also divided into three categories: beams, frames, trusses. Force. A force represents the action of one body on another, and it's generally characterized by its point of application, its magnitude, and its direction. Forces acting on a given particle, however, have the same point of application. Each force considered completely defined by its magnitude and direction. The magnitude of a force is characterized by a certain number of units. The SI unit used by engineers to measure the magnitude of a force are Newton, and its multiple kilonewton equal to 1000 newtons, while the US customary unit used for the same purpose are pound lb, and its multiple kilopound keeps equal to 1000 lb. The direction of the force is defined by the line of action. And the body force, a force that occurs across a distance between two separated bodies. Some examples of body forces are gravitation and magnetic attraction. Contact force, a force that occurs as a result of direct contact between two or more bodies, a push or a pull. Some examples of contact force are the tries of a truck pushing downward to the deck of a bridge. In another example, your hand pushing on a chair or a door. We have two types of force: concentrated force and distributed force. Concentrated force, a force that is applied at one point or over a distance that is a very small in comparison with the number of structure. For example, your foot pushing downward on your floor of your room would mostly like to be presenting a concentrated force. Distributed force, a force that is separated over a significant length or area. The weight of snow pushing downward on your floor of your building would be presenting a distributed force, and you could find the distributed force by multiplying the length and the force. Line of action. The line of action is the infinite straight line along which the force acts. Components of a force. Principle of transmissibility. This states that the condition of equilibrium or motion of a rigid body will remain unchanged. If a force acting at a given point of the rigid body is replaced by the force of the same magnitude in the same direction but acting at the different point, provided that the two forces will have the same line of action. We have two type of force systems: concurrent force system and non-concurrent force system. Concurrent force system: a system in which the line of action of all forces intersect at one point. In a concurrent force system, uh, the force vector can be added together as a single resultant force. Non-concurrent force system: a system in which the line of action of all forces do not intersect at one point. In a non-concurrent force system, the force vectors cannot be added together as a single resultant force. Rigid body. A rigid body can be considered as a combination of large number of particles in which all the particles remain at the fixed distance from one another, both before and after applying a load. This model is important because the material and property of any body that is assumed to be rigid will not have the same considered when studying the effects of forces acting on a body. In most cases, the actual deformations occurring in structure, mechanics, or mechanism and likely relatively be small, and rigid body assumption is suitable for all analysis.